If a tube contains 25 microliters of serum and 75 microliters of saline, what is the dilution? When I look at my dilution problems, I first figure out what is my total volume. If you look at this example, we have 25 microliters of serum and 75 microliters of saline. So that would mean we would have a total volume of 100 microliters. When you take 100 and divide it into 4 parts, you can see that each piece would be 25 microliters. So we've got 25 in each section. Total volume is 100. One of those equals serum. The other 75 are saline. So when you look at this picture, one part out of a total of 4 parts is serum. So we would have a 1:4 dilution. We are going to convert a glucose of 450 milligrams per deciliter to millimoles per liter. We are going to do this in 4 steps. I'm going to list the steps first. First step is converting from deciliters to liters. The second step will be converting milligrams to grams. Our third step is going to be using the fact that there is 180 grams of glucose in 1 mole of glucose. Our fourth step will be converting moles per liter to millimoles per liter. Okay, so starting out with the 450 milligrams per deciliter. If there are 450 milligrams in 1 deciliter, then 1 liter would have 4,500 milligrams of glucose. All I did was convert deciliters to liters. There are 10 deciliters in 1 liter. So therefore, 450 milligrams is the same as 4,500 milligrams in 1 liter. Step 2, we know that since there are 4,500 milligrams, if we convert that to grams, we would have 4.5 grams of glucose in 1 liter. Okay? So all we did was convert milligrams to grams in our second step. With our third step, we know, because we were told, that there is 180 grams of glucose in 1 mole. So for our fourth step, we take the 4.5 grams of glucose divided by the gram molecular weight, which is 180, and that gives us 0.025 moles per liter. Well, that's great, but we need millimoles per liter, not moles per liter. In order to convert moles per liter to millimoles, we would take the 0.025 moles per liter. We're going to move our decimal place over 3 places to the right. So we would then have 25 millimoles per liter of glucose. Our molecular weight is 98 and the valence is 2. I've supplied you with a bunch of equations here to choose from when trying to calculate these problems. First of all, we need to see what is it that the question is asking us. Well, it is saying what is the normality. If you look through the equations, the one that helps you figure out normality is the last one, and it is normality equals molarity times the valence. In order to figure out this problem, we also need to figure out molarity first. So in order to use this problem, we do have to use molarity. If we use the one on the top, molarity equals grams divided by liters times 1 mole over the gram molecular weight. It will help us figure out the molarity of this problem before we can figure out normality. So let's go ahead and plug this in. Here we have molarity equals grams. As we can see in the problem, we have 3 grams. If we divide this by the number of liters, and you see it says liters, we have to stay with liters. We have 250 mils up here. We have to convert that to liters. So that gives us 0.250 liters. We then multiply times 1 mole over the gram molecular weight, which we know is 98. When we calculate this, we take 3 divided by 0.250 times 1 divided by 98 gives us 0.12 molar. But we're not done. The equation said what is the normality, not what is the molarity. In order to figure out the normality equals the molarity times the valence. So in this case, normality equals 0.12 times 2. 0.24 normal. So the answer is 0.24 normal. For this problem, we are going to see how many grams of calcium sulfate are needed to prepare 1 liter of 0.5 molar solution with a gram molecular weight of 136. Now we have the same problems here, or the same calculations listed that I had in the last frames, but we're going to be using a different one. When you're trying to figure out which of these problems that you want to use to solve your situation, you need to see what is the question asking. In this case, how many grams? Well, if you look at your choices here, you see that there is one that helps you figure out how many grams. That would be the last one here. Grams equals the molarity times gram molecular weight times the liters. So let's go ahead and plug this in. So grams equals the molarity, which is given to you in the problem, 0.5, times the gram molecular weight, which is given to you in the problem, is 136, times the liters, given to you here, is 1 liter. Keep in mind that if this were given to you in milliliters, you would have to convert that over to liters. In this case, the problem is just giving us a liter. When you plug that in, 0.5 times 136 times 1 equals 68 grams. You would put the 68 grams into a flask, then fill it up to the 1 liter mark with water and mix.